We're going to talk about determining the identity of the chemical reaction or reactant lab that we're doing tomorrow. And mainly I want to focus on the pre-lab questions. I may talk a little bit about how to kind of set up the procedure after we get done with the pre-lab questions. But I think you guys maybe will have a better idea of what we're talking about after we go through these questions. So first question, what is an empirical formula? I think hopefully we know the answer to that one. It's basically just the simplest whole number ratio. So an example of that, again, we did a couple examples of this the other day, but the empirical formula for C2H4 is just CH2, okay? So just because you find an empirical formula for something, it doesn't necessarily mean that that is the actual chemical formula, especially if we're talking about a molecular compound. But when we're talking about an ionic compound, the empirical formula is really the formula of that compound, okay? And the reason that's significant is because we're kind of talking about the reaction between copper and oxygen. Copper's a metal, oxygen's a non-metal, so that's probably going to form an ionic compound. So once we find the empirical formula of the beginning compound, whatever it is, that's probably the actual formula of that compound, since it's ionic, okay? So empirical formula, just the simplest whole number ratio. And that's what you need to know for number one. From where do we get that information? Okay, that's maybe a little bit more tricky. But we're going to get that information from usually the mass percent of the elements in the compound. Okay, so the mass percentage, because remember, when we're finding an empirical formula, the rhyme is percent to mass, mass to mole, divided by small, multiplied to the whole. Okay, so usually what we're starting with is a mass percentage. And if we know the percent of the elements in the compound, or we could even start with just knowing the masses in the compound, because we can always change that to moles. So either the mass percentage, or if we just know the mass of the elements and we also know the total mass of the compound, then we would be able to figure out the empirical formula of the compound from that. Okay? So now here's where it gets a little bit more tricky. And I think this is going to help you guys. Question is, what do we know about the product in this experiment? Okay, so you're going to have to think about this a little bit. We had this red powder sitting in here in class today. This says oxide of copper. Okay, and I think we discussed a little bit about the fact that this oxide of copper, or maybe just copper, depending on what it is, when we heat it up, it's probably going to react with oxygen in the air. Okay? So we've got to figure out what would the product probably be. Now, assuming that there's some sort of copper in this compound, because it looks like, it looks like copper to some extent, right? So we're going to assume that they at least got the copper part right. Well, then the question is, what would the product have to be? If the copper is reacting with oxygen, then what is our product going to be? I'll let you interact since you're here.
Copper.
Okay, copper oxide. Now, can we just say copper oxide? Okay, copper's a transition metal, so we have to say something additional about it. We can't just say copper oxide, right? It's either copper 1 oxide or copper 2 oxide. But the thing is, if you think about it, so copper 1 oxide, I don't want to give too much away here. What's the formula for copper 1 oxide? Cu2O, okay? And the formula for copper oxide is CuO, okay? Copper 2 oxide would be CuO. So those are our two possibilities for the product, okay? if we are heating this thing until it reacts with probably as much oxygen as possible, which one of these two compounds has a higher ratio of oxygen for the amount of copper that's in it? The second one, right? Okay. So probably, now this is taking a little bit of a leap here, but probably the one that we're going to form, if we're heating this thing up so that it can react with as much oxygen as possible, it's probably going to be the copper CuO, copper 2 oxide. Okay. Now, turns out this question is answered in number 7. Whoops. Didn't mean to cross that out. Meant to underline it, but CuO down there. Okay. So we're probably going to assume that the product that's being formed is CuO. Okay? And so that's why it says, is this true for everyone? Because if we had discussed this in class, there might have been a little bit of debate about whether it was the Cu2O or the CuO that's being formed. Okay? But probably I would have helped you to land on the CuO eventually. So then number 4, what are the reactants in this experiment? Well, that's kind of a tricky question because we don't know what this is for sure, right? But let's talk about the possibilities. What could it be? What could the reactants be in this experiment? Okay, it could be copper and oxygen, right? So it could be something like this. Are there any other possibilities? Okay, so if it's an oxide of copper, if it's actually labeled correctly, whoops, no way. I was just going to cut it off the screen like that. Yeah, I'll do it up here. That doesn't make a lot of sense, does it? Because nothing changed. But, and see, this is why I wish we had...
Have someone unlock the doors for the gym foyer area, please? The doors unlocked for the gym foyer area, please. Thank you.
This is why I wish we could have discussed this in class, because I wanted someone to get there.
Can I ask a question?
Yeah.
The reactants in the experiment that you're going to do, or the experiment that you...
No, the reactants in the experiment we are going to do. Okay? So, so the reactants in the experiment we are going to do, we would think would be Cu plus O2 probably. But there is one other possibility. What if this really is an oxide of copper? Is there another oxide of copper besides CuO? We just talked about it, right? What about this? Could that happen? See, this is a tough inquiry lab to first start with. That's why I'm giving you a lot of guidance here. Now, we're going to have to figure out how to balance that, and that could be a little bit tricky, okay? But I think that might be able to happen. Because if you think about it, so this Cu2O here, I mean, you already told me that the highest possible ratio of oxygen to copper is CuO, right? So we've got something with a lower ratio of oxygen to copper. We add some more oxygen to it, and now we have the one that has the higher ratio of oxygen to copper. I mean, that seems feasible. So we kind of have a couple possibilities here. Either this powder is copper, and it's going to react with the oxygen to make CuO, or this is Cu2O, okay? This is copper 1 oxide. And fortunately, I didn't show you any copper 1 oxide last year, so you don't know if this is the right color for copper 1 oxide or not. But that could be maybe copper 1 oxide, and maybe the label is right. Okay, so those are kind of our two possibilities right now. So then when it asks what's the formula for the powder, well, we have two possibilities here. Okay, our two possibilities. This is either copper or it's Cu2O, copper 1 oxide. Probably not copper 2 oxide because it still did react with the oxygen in the air, and it wouldn't make sense for it to react if it was just copper 2 oxide. Okay? So then when it's asking what's the equation for the reaction, we kind of answered 4 through 6 all sort of together. Okay? But the equation, again, we've got two basic possibilities here. We could have just the copper plus oxygen forming CuO, and we'd have to balance that. I'll leave you guys to balance that because you got to do at least something. Or we could have Cu2O plus O2 yields CuO. Okay? Those are kind of our two possibilities here. Okay, now the questions start getting kind of basic here, but they're trying to help you to think about the calculations you're going to have to make at the end of the lab. So looking only at the product CuO, what elements are present? Fairly obvious, right? Okay. Copper and oxygen are the elements that are present there. From what reactant on the left does each of the elements come? Okay, so once again, we've got two possibilities there. If this is the reaction that we're working with, then the copper obviously comes from copper, and the oxygen comes from oxygen, okay? But if it's actually this reaction that's happening, the copper is coming from the Cu2O, and the oxygen is coming from two places, from the oxygen in the Cu2O, but it's also coming from the O2, the oxygen in the air. All right? So then number 9, if we are to believe the law of conservation of matter, what is true about the mass in grams of each of the elements in the product? What can we say for sure is true here? Right, so the mass, regardless of which equation we're using, the mass of the copper that's on the right side must come from the mass of the copper on the left side, okay? That's going to help us with the calculation. It's really important to kind of keep that in mind, okay? Now, the mass of the oxygen is going to come either from just the oxygen, if we're talking about the top equation, or it's going to come from two places. But if we add up the mass of the oxygen on the left, the mass of the oxygen on the right, it should be the same, okay? Now, that's a little bit tougher to deal with because we're not really going to be able to measure the mass of the air so much. But what I want you to think about is there a way to sort of design our experiments so that we could figure out how much copper there is in the product? Okay? By maybe comparing the product to the reactant. If we could figure out how much copper is there, then that might help us to decide which of these equations is actually the right one. Okay? So that's kind of, I mean, does that help a little bit with figuring out kind of what you need to do here? Okay? Now, as far as the procedure is concerned, you can design the procedure how you want to design it. All these are down here are just kind of suggestions, okay? So it is strongly suggested that you heat the powder. Kind of makes sense because that's what they did at the beginning here, right? So the heating, now this is important, okay? Heating measured portions of the red oxide of copper results in a chemical reaction. So we probably want to measure it and we want to heat it. I would say that much we probably want to make sure that we do, okay? Now how you measure it exactly and how you heat it exactly is up to you, except for probably don't use a hot plate. I'll tell you that. So then these basically just give you some tips for how you might want to design your procedure, and you guys can look through these, and I think you'll be fine there. The designing of the procedure really is not that bad because we've done things similar to this last year, okay? So once you have your procedure written, again, make sure that you include a safety section, all right? Because we're working with fire here, so you need to talk about how you will stay safe in this lab. And then once we get down to the analysis parts, that's where we'll answer some of those final questions. But we'll worry about that after we actually collect the data. Okay, the calculation section on this might be a little bit tricky, but we'll figure that out together. Okay? So that's the plan. Do you have any questions on what we need to do for tomorrow? Okay, good. So that's that. Just make sure you have that procedure done before you come into class, and we'll see you tomorrow when we do the lab.